Okay, this review video is of evaluating limits. Okay, there are quite a few of these that we're going to walk through. My recommendation: pause the video, give the one you're on a shot, restart it when you're ready. That way you get that gauge of how you're doing. So you can restart it either when you are stuck or have a right answer. There will be two of each type of limit. So if the first one is a little bit rough, there will be one immediately following it that'll be the same type. Okay, so if you're going to pause the video, go ahead and do so now. Okay, plugging in 6, we get 1/3 minus 1/3, which is 0 over 0, which cannot happen. So then we're looking at what else we can do. In this one, it would be multiplying everything by those denominators, 3 and x minus 3. Okay, what this gives me then is the next step, which is the limit as x approaches 6. Distributing in, my x minus 3's would cancel, which would leave me with just 3. My 3's would cancel, which would leave me with just x minus 3. All over 3 times x minus 6 times x minus 3. Okay, distributing that negative in, we'd have the limit as x approaches 6 of 3 minus x plus 3. All over 3 times x minus 6 times x minus 3. Which gives me, adding those 3's together, the limit as x approaches 6 of negative x plus 6 all over 3 times x minus 6 times x minus 3. Okay, these ones do simplify. If I pulled a negative out of this numerator, I would be left with x minus 6. So again, if I pulled a negative out of that numerator, I'd be left with x minus 6, which means the x minus 6's can cancel. Now when I plug in 6, I have negative 1 on top over 3 times 6 minus 3, which is 3, which is an answer of negative 1/9. Okay, go ahead and pause the video, give the next one a shot, restart it when you are ready. Okay, plugging in 4, we have 3/2 minus 3/2, which is 0 over 0, so we can't have 0 over 0, so we're looking at what else can I do. I can multiply top and bottom by 2 times x minus 2. This means distributing, we have our 2's would cancel, leaving me with our 3 and x minus 2. Distributing here, we have our x minus 2's cancel, which would leave me with negative 3 times 2, which is 6. Over on the bottom, 2 times x minus 4 times x minus 2. Okay. Distributing, this gives me the limit as x approaches 4 of 3x minus 6, and then the minus 6 at the back. So again, 3x minus 6 with the minus 6 at the back, and 2 times x minus 4 times x minus 2. Okay, this simplifies to 3x minus 12 over 2 times x minus 4 times x minus 2, which simplifies one step further, because if I factor out a 3 on that top there, I end up with 3 times x minus 4 over 2 times x minus 4 times x minus 2. Those x minus 4's can cancel. And so now when I plug in, I have my 3 on top. On bottom, I have 2 times 4 minus 2, which is 2, which is 3/4. Okay, so those are our ones that I call the extra denominator ones. Okay, next ones. Go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, when I plug in negative 1/2 in here, I get 1/2 plus 9/2, which is 10/2, or 5 minus 5, which is 0, over 1 minus 1, which is 0. I can't have 0 over 0, so I am factoring. Factoring this numerator, I'm looking for two things that multiply to negative 10 and add to negative 9. That would be 1 and negative 10. So I'm going to have 2x plus 1 and x minus 10. It's always good to double check that you factored correctly by FOILing. 2x times x is 2x squared. Negative 10x plus 1x is negative 9x. That's not true. I apologize. This should be 5. Negative 10x plus 1x is negative 9x, and 1 times negative 5 is negative 5. Okay, so I know I FOILed correctly. In the bottom we have a difference of 2 squared, so 2x plus 1 times 2x minus 1. The 2x plus 1's cancel, so now when I plug in, I have negative 1/2 minus 5, which is negative 11/2, divided by negative 1 minus 1, which is negative 2. And so my answer is 11/4. Okay. Okay, go ahead and pause the video, give that next one a shot, restart it when you are ready. Excuse me. Okay, next one, plugging in our 5, we get 10 minus 10, which is 0, over 25 minus 20 minus 5, which is also 0. 0 over 0 is not a possible answer, so we're factoring. On top here, I can factor out a negative 2, so we'd have negative 2 times x minus 5. All over on bottom, this would be x minus 5 and x plus 1, which simplifies. So now when I plug in, I have negative 2 on top, 5 plus 1 on bottom, which is negative 1/3. Okay? So that's factoring with limits. Next up, we've got these two. Okay, so go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, for this one, there's actually a couple of different options you have for yourself here. Technically speaking, when I plug in on this one, I don't get 0 over 0. Technically speaking, when I plug in on this one, I get 4 plus 4, which is 8, minus 15, which is negative 7, over negative 1, which is 7. So actually, when I plug into this one, go ahead and show that negative 7 over negative 1, which is 7, I actually already have an answer. Now, if you were to have factored that wouldn't be a problem. This one does factor. It's x minus 5, x plus 5, x minus 3 over x minus 3, which simplifies. When you plug in 2 here, you still get 7. So it wouldn't have been a problem to factor, but you didn't need to, because I didn't get 0 over 0. Okay? Okay, go ahead and pause the video. Give the next one a shot. Restart it when you're ready. Okay? This one also doesn't need to factor. When I plug in negative 3, I get negative 6 over 0, which does not exist. It also does factor, but you don't need to. In fact, this case, you don't really want to. Because the factoring doesn't allow a kind of a nice reduction like this prior one did. If I factored this denominator down here, it's a cubic factoring, so we'd have x plus 3, x squared minus 3x plus 9, and so nothing simplifies here. However, if I plugged in, I'd get negative 6, let me slide this over, I'd get negative 6 over 0 times 9 plus 9 plus 9, which is 27, which is still negative 6 over 0, or does not exist. So So again, it's not a problem to factor when you don't have to. It's just not really necessary. It's extra work, and you might make an error factoring. So it might have been better to just leave it alone and plug in there. Okay, so that's what I call plugins. Okay, next up, we've got these two. So go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, when I plug in 3 here, I get root 4, which is 2, minus 2, which is 0, over 0, which is not allowed. So this is where I'm going to be multiplying by the conjugate. So I'm going to go ahead and lengthen this times. This is going to be root x plus 1 plus 2 over root x plus 1 plus 2. Nice thing about multiplying by the conjugate is the outside and inside always cancel. So we'll have our first x plus 1 times x plus 1 is x plus 1. Outside and inside will cancel, which will leave me with my last, negative 2 times 2 is negative 4. On the bottom we have x minus 3 times root x plus 1 plus 2. X plus 1 minus 4 is the same thing as x minus 3 over my denominator, which means the x minus 3's are going to cancel. And so what am I left with? I'm left with 1 over, plugging in root 3, we have root 4, which is 2 plus 2, which is 1/4. Okay. Okay, go ahead and pause the video, give this next one a shot, restart it when you are ready. Okay, when I plug in 5 here, I get 4 minus root 16, which is 4. 4 minus 4 is 0 over 0, which can't happen. So this is where I'm going to multiply by my conjugate. We're going to have 4 plus root 3x plus 1. Okay, again, nice thing about multiplying by the conjugate, outside and inside will always cancel. So my firsts are going to be 16. Outside, inside cancel. Last, we have negative 3x plus 1. On the bottom, we have x minus 5 and 4 plus root 3x plus 1. Okay, distributing that negative, we have the limit as x approaches 5. Let me slide this over. Distributing the negative would be 16 minus 3x minus 1. Which means, combining like terms here, 16 minus 1 is 15. So it would be the limit as x approaches 5 of negative 3x plus 15 all over x minus 5 times 4 plus root 3x plus 1. Negative 3 factors on top. Which will allow my x minus 5's to cancel. Now when I plug in 5, I have negative 3 on top over 4 plus 15 plus 1 root, which is root 16 or 4, which is negative 3/8. Okay, so those two are multiplied by the conjugate. Last but not least, we have all of our infinities and negative infinities here. So I've got 6 of these. Okay, I'm going to walk through all 6 of them at this point. So you can either pause the video and do all 6 and then restart it when you're ready, or you can pause the video, do 1, restart it, watch the 1, pause the video again, restart it, watch the second. So on and so forth if you'd like. I'm going to go from this one to this, to this, to this, to this, to this. So I'm going to go sideways as I go down the row. Okay? So go ahead and pause the video, give whichever ones you're going to a shot, and then restart the video and either you stuck or you have an answer. Okay, so infinity or negative infinity, we're looking at top heavy, bottom heavy, equal heavy. So in this one, these are equal heavy. So reducing 2 over 6 is 1/3. Okay, next one. Top heavy, bottom heavy, equal heavy. In this one, we are equal heavy. So reducing 3 over 1 is 3. Next one, top heavy, bottom heavy, equal heavy. This one here is bottom heavy. We have an x squared on the bottom, but only a 2x on top. When we're bottom heavy, our answer is 0. Next one, top heavy, bottom heavy, equal heavy. These ones are equal heavy because we have a power of 3 on top and a power of 3 on bottom. And so this one here on top has a leading coefficient of 6. This one has a leading coefficient of 4. 6 over 4 is 3/2. Okay. Next one, top heavy, bottom heavy, equal heavy. Okay, well this one here is equal heavy. We have a degree of 2, 2, and another 2, because that one's squared, so this is a degree of 6. And down here we have a degree of 3, and another 3, because of that squared, so it's a degree of 6. So equal heavy, up top here we have 3, 1, and 1, which makes 3, over 3 and 3, which is 9, and 3 over 3 is 1/3. Okay, last one, top heavy, bottom heavy, equal heavy. Okay, this one here is top heavy. We have a degree of 1, 2, and another 2, which is a degree of 5. Over on the bottom, degree of 2 and 2, which is a degree of 4. So bottom heavy, if we are bottom heavy, our limit does not exist. And that's evaluating limits.